Hi guys, in this video we're going to talk about software design patterns. Design patterns are broadly divided into three categories: creational, structural, and behavioral. In this video we'll focus only on creational design patterns, including factory, singleton, builder, and prototype. I'll cover the other categories in separate videos. Let's start with a simple example. Whenever we construct a building, we need raw materials like bricks, cement, and steel. Similarly, in software development, we use OAP concepts like abstraction, polymorphism, inheritance, and encapsulation. But knowing concepts is not enough. The real skill is knowing where and how to use them effectively. Also, remember, design patterns are guidelines, not strict rules. If a pattern doesn't fit your use case, don't force it, adapt or skip it. Let's begin with the factory pattern. Think of a real-world factory. You provide raw materials as input, and you get a finished product as output, but the internal process is hidden. Similarly, in software, the factory pattern encapsulates object creation. The client only asks for an object, it doesn't worry about how it's created. To implement the factory pattern, we follow three steps. First, create a product interface. In our example, we have a logger interface with a log method. Second, create concrete classes like console logger, file logger, database logger. Third, create a factory class. This class decides which object to return based on input. For example, if input is console, return console logger. If input is file, return file logger. If input is invalid, throw an exception. This approach gives us loose coupling, open, closed principle, meaning we can add new loggers without changing existing code. Next is the singleton pattern. This pattern ensures that only one instance of a class exists throughout the application. It is commonly used for shared resources like database connections. Think of it like a central government. There's only one at a time, and everyone accesses it. To implement singleton, make the constructor private, create a static instance. Variable, provide a public getInstance method. Now, there are two approaches. Lazy initialization. The object is created only when it's needed for the first time. Eager initialization. The object is created as soon as the application starts. In both cases, all calls return the same instance. This helps in reducing memory usage, ensuring a single shared instance. Now let's look at the builder pattern. This pattern is used to construct complex objects step by step. Instead of creating an object in one big constructor, we build it gradually. In this example, we're building a computer object. We specify required parameters like RAM and HDD, optional parameters like graphics card and Bluetooth, then we call the build method. This makes the code easy to read, easy to maintain, more flexible also. The constructor is private, so objects can only be created through the builder. Builder pattern is very useful in real-world scenarios like creating game characters with weapons and accessories, building meals in a food app, configuring complex objects with many options. Finally, we have the prototype pattern. This pattern is used to clone existing objects instead of creating new ones from scratch. It's especially useful when object creation is expensive. We define a prototype interface with a clone method. Then we implement it in classes like circle. We can also maintain a prototype registry where we store predefined objects. When needed, we simply clone them instead of creating new ones. There are two types of cloning: shallow copy, the original and clone share the same references. Deep copy, the clone has completely separate memory. In deep copy, changes to the clone do not affect the original object. So, in this video, we covered factory pattern, singleton pattern, builder pattern, prototype pattern. In the next video, we'll explore structural and behavioral patterns. If you found this helpful, don't forget to like, subscribe, and share your feedback.